So throughout the next part of the course, we are going to be looking at functions and moving them all over. And but we're getting ahead of ourselves. Here is a function. F of x is equal to the absolute value of x. And the first thing we want to do is see what this looks like. And the best way of doing that is to graph it, of course. So this is x, this is f of x. So let's give x certain values, and bear with me, but since I know what this is going to look like in advance, I'm starting with 0 right down there. So the absolute value of 0, of course, is equal to 0. So the conclusion we come to is that this is the point 0, 0. That's where we start. When x is equal to 1, the absolute value of 1 is 1, and this is the point 1, 1. When x is equal to 2, the absolute value of 2 is 2, and that point is the point 2, 2. Very interesting. 3, the absolute value of 3 is 3. This is the point 3, 3. Wow, very interesting, right? When x is negative 1, the absolute value of negative 1 is 1. So when x is negative 1, y is equal to 1. When x is negative 2, the absolute value of negative 2 is 2. Therefore, this is the point negative 2, 2. I won't keep making that sound. The absolute value of negative 3 is 3, negative 3, 3. Okay, well, very interesting. Let's see what this looks like. So let's draw, well, we're going to be sketching. This is the key word for us in this class, is sketching. And when I say sketch, all I want is the x-axis labeled, the y-axis labeled, maybe a 0 in the middle, maybe some values like 1 and 2 and 3 and 4, and maybe a few points over here, just to get a feeling for what this looks like. Okay, now we're ready to see what this graph looks like. So when x is equal to 0, y is equal to 0. This is where it starts, right here. And when x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 2. When x is equal to 3, y is equal to 3, and so on. When x is equal to negative 1, y is still equal to 1. When x is negative 2, y is still equal to 2. When x is negative 3, it's still 3. And if we were to go beyond that, when x is equal to 4, y is still going to be equal to 4. And if we connect these points, this is what it looks like. And it keeps going in that direction, actually. This is the most basic sketch of the given function. And when we have that, we call it the parent function. The parent function is very, very important to know. when I start moving things around, we always start with the parent function. And the parent function is the simplest version of it, which starts at 0, 0, and then goes wherever it goes. But you always start with the parent function before you start to transforming things. Once you know that the parent function has been sketched on a graph, then you could move the graph to the right. You could move the function to the left. You could move it up. You could move it down. And we're going to be looking at all those possibilities right now. But first, this is the general form of the function f of x equals the absolute value of x. This is what it's going to look like. F of x is equal to a times x minus h, the absolute value of x minus h, plus k, where h comma k is always going to be where the two lines will intersect, the vertex. That's a very important point because that's where everything is going to begin. Now let's take a few examples. Let's go down here where we have more room. Okay, so what I would like to do now is graph f of x equals the absolute value of x plus 2. So if you wanted to graph this, what you would do is first say to yourself, what is the parent function? And, right on the side here, we would draw a parent function. There it is, right? That's what we indicated up here when we actually graphed the function originally. This is the parent function. So we take the parent function, the x-axis, the y-axis, and we take this, and the 2 has the effect of actually raising it up so that the vertex is now going to be at that point. So it's going to go like this. And this vertex now is the point when x is 0 and y is 2. So that positive 2 has the effect of raising the parent function up to a starting point of 2 on the y-axis, as opposed to f of x equals the absolute value of x minus 2. That will mean, and notice I modify the axes accordingly. So that the vertex is now at 0, -2, and that's where it's going to start and go up in that direction. So this 2 has the effect of raising and lowering the graph. Next, f of x equals the absolute value. Oh, I don't want to get rid of everything here, but f of x equals x minus 1. Let's just leave it at that. Okay, well, the vertex is now going to be at one, okay, so it's always going to be the opposite of what this sign is. If this sign is this sign will always be a negative because in the formula that I gave you earlier, that's a negative in there, right? So whatever H is will be positive. So therefore, 1, and there's nothing out here at all, so the Y will be 0. So the vertex is going to be where H is equal to 1 and K is equal to 0. And therefore, we take the parent function. So remember what the parent function looks like, very important. And we're going to move it over so that it now starts at x equals 1 and looks like this. And this is the point 1, 0. As opposed to f of x equals the absolute value of x plus 1, which will go to a starting point over here of -1, 0. And this is the vertex. The vertex will be at -1, 0. So, to sum up then, when this is a negative, it moves the parent function in the positive direction. When this is a positive, it moves the parent function in a negative direction. We should write that. I know you're probably writing because if you're taking notes, but let's, well, I don't want to write it to tell you the truth. So this moves the function in a positive direction. And this moves the function in a negative direction. This right here. If it's positive, it goes in the negative direction. If it's negative, it moves it in the positive direction. This right here. And this right here. Nobody's saying anything. I hope that means that people are kind of understanding this. I hope. Now, the only thing left for us to consider is what happens when we put a negative in front of the function. When you put a negative in front of the function, then, now remember, we always start with the parent function. So whenever you're doing something different, always revert back to the parent function right here. This is the parent, right? So when there's a negative, this had a positive, but when it's a negative, that means that this will be upside down. So it'll still be the same vertex, 0, 0, but it'll now be upside down. These are all the different things that could happen to a function. Raising it up and down, raising it to the right and to the left, and flipping it over so that it's upside down. Those are all the possible things. Actually, there are other things that could happen, but I'll talk about those a little later. So that's the function that I would like to consider. And this is the similar type of function that will be on the exam on Monday. That's why I'm now going to pivot to what's going to happen when we change everything. We change the vertex. We change that. In other words, keep in mind what I wrote here. And remember that, this can be, for now, A can be either positive or negative. HK is the vertex. So the first thing we want to know is, what is the vertex? And that's going to be the point. Remember, it's the opposite of -4. So that'll be +4, -2. That will be the starting point. So the first thing you should look at is the parent. And then, in many cases, that's the first question. The first question you will be asked is, graph the parent function. This is the parent function for f of x equals the absolute value of x. That's the parent. But we don't want the parent. We want this function that I just gave you up here, this one right here. And the vertex will be at the point 4, -2. So we start at 4, -2. That will be the starting point. So we've taken care of H and K, which tells us the starting point for the graph. And now we assume it's going to look like that, with the exception of the fact that there is a negative sign here, meaning that instead of it looking like this, it's going to look like this. And that's the answer to the question. And that's putting everything together into the same problem. We've taken the original function that we spoke about, and we graphed, and we analyzed, and we've now modified it in this manner. We've changed where it starts, which I call the vertex. It's not really called the vertex. They save that for a concept that we'll be talking about in chapter 2. But I like it because the vertex kind of tells us that that's the starting point. So the starting point, the vertex, is at the point 4, -2. And normally we just would have, drawn the graph, except that there's a negative, which means it's upside down. Okay, so I would like to give you a problem to try. So given that f of x is equal to the absolute value of x plus 5, -1. And I'd like you to do the following. Find A, the parent function. And B, sketch f of x. Okay, I'll give you a couple of moments to do that. So, part A, graph the parent function. And that's just, the basic looking function. F of x is equal to the absolute, and this is the answer to the question, that part of the question. Not just simply graphing it, but also indicating what it is. That this is the parent function, f of x equals the absolute value of x. And now let's actually graph this thing. So first of all, the starting point, which I'm calling the vertex, will be, now remember, it's the opposite sign. So if this is +5, that will be -5, and that's h, and k is going to be -1. So we draw a graph, just a sketch, just give me a sketch that's very, very plain and very crude without any, other indications. And we start by graphing that. -5, -1 would be right over here. -5, -1. And remember, so we've taken the parent function now, and we've taken this vertex and moved it to a different location. And there is the new location. And then now we look for a negative. Is there a negative here? No. Therefore, it's not going to be upside down. It's going to be, indeed, right side up. And that's what it looks like. Now, some professors may be saying, okay, tell me what that point is. Tell me what I don't care. I don't care about that. All I care about is that that the starting point has changed from the original parent function, and that because there's no negative there, it's gonna go up.